Okay, in section 5.4.35, the following data represent the number of different communication activities used by a random sample of teenagers in a given week. So you have your activities, 0, 1 to 2, 3 to 4, 5 plus, and there's your total. You have a row which contains male, female, and then you have your totals. Okay, now what we want to do is we want to be able to find out what are the events that a teenager is male and 5 plus activities is independent. And then recall from our definition that two events E and F are independent if the occurrence of the event E in a probability experiment does not affect the probability of event F. Another way of looking at that is that if these two events are independent, is that if the probability of event E is selected, provided that F has already been selected, is equal to the probability of event E, or vice versa if there's equality there. So we want to prove whether these events are equal or not. If they are equal, then they are independent. If they are not equal, then they are dependent. So we're going to compare the probabilities of male and the probability of selecting a male, provided that 5 plus activities has been selected. So in order to find the probability that a teenager is male, we're going to divide the total number of males by the total number of teenagers. So if you take a look up here in that row, the total number of males is 200 and the total overall is 400. So the probability that a teenager is a male is 200 divided by 400, which is 0.5. Now, to find the probability that a teenager is a male, given that the teenager uses 5 plus activities, we're going to divide the number of males using 5 plus activities by the total number of teenagers using 5 plus activities. So going back up to this column for 5 plus activities, the total number that the male is 37. And we're going to divide it by the total in that column, which is 110. So therefore, we're going to take 37 divided by 110, which gives us 0.336. Now, these probabilities do not equal each other. And again, as we stated up here, because they do not equal each other, then they are dependent. Now, if these two numbers were equal to each other, then we would say that they are independent. Now, we're going to do the same thing with determining are the events female and 0 activities independent. So we want to find the probability that a teenager is female. So again, let's go back up here and we can see that the total number of female out of all of them is 200, and we're going to divide by the total number of teenagers, which is 400. So we get 200 divided by 400, which is 0.5. Okay, and then we're going to find the probability that a teenager is a female, given that the teenager uses 0 activities. So if we take a look at the column for 0 activities, we can see that the female is 23, and we're dividing by the total, which is 46. So 23 divided by 46 gives us 0.5. Now, as you can see here, that these two probabilities are equal. So the events that we get for female and 0 activities are now independent because these two probabilities are equal. Now, are the events 0 activities and 3 to 4 activities mutually exclusive? Now again, we also always need to find out what does mutually exclusive mean, or anything else that we have when we have a question like this. Two events E and F are mutually exclusive if they have no outcomes in common. What that means is the probability of E and F is equal to 0. Now note that each teenager can only be listed in one category. So for example, a teenager cannot use 1 to 2 communication activities while simultaneously using 3 to 4 communication activities. So therefore, the probability that a teenager uses 0 activities and 3 to 4 activities at the same time is 0, because it would not work. So the events 0 activities and 3 to 4 activities are mutually exclusive because they have nothing or no outcomes in common. Now, are the events male and 0 activities mutually exclusive? Well, recall that two events E and F are mutually exclusive if they have no outcomes in common, meaning that if you have the probability of event E and F is equal to 0. Now, we want to find the probability that a teenager is a male and he uses 0 activities. So, the probability that the teenager is male and has 0 activities out of the entire survey. So here we have 23 teenagers that are male under the column of 0 activity, which is 23. And then we're going to divide it by the total number, which is 400. So therefore, in part D, 23 divided by 400 gives you 0.0575. Now, that number does not equal 0, and therefore, since they don't equal each other, then we would say that it is not mutually exclusive.